My name is Jacob Wirt. I'm an ABE Machine Systems Engineering student.
I'm Jonathan Welchie. I'm also a Machine Systems Engineering student.
I'm Yichen Li. I'm from Machine Systems Engineering.
Daniel Skelton, Machine Systems Engineering.
Ashley Johnson, Machine Systems Engineering, and our project is the quarter scale tractor.
Quarter scale tractor, like quarter or 1/4?
Like 1/4.
1/4. Let's take a look. So, is it a competition tractor or?
It is. It's based on the student design competition sponsored by the American Society of Agricultural and Biological Engineers. Our competition is at the beginning of June every year, and we build a new tractor from the ground up.
Excellent. So, give me the big overview. How many horsepower? How fast does it go? How much does it pull? Kind of big.
Horsepower, 31 horsepower, Briggs & Stratton engine. Unloaded, in theory, it should be able to go about 11 miles per hour. And it's designed for a max chain load of about 2,600 pounds force.
Okay, gotcha. And traction tires, this baby is designed to pull.
Correct.
Designed to pull. Okay. Well, the only way it could pull is if it had a really good drivetrain. Does anybody around here know about the drivetrain? Who would that be?
I know a little bit about it.
You would?
Yeah.
Well, tell us about it.
Our drivetrain this year is centered around an electromechanically actuated CVT.
Holy cow, slow down. CVT.
Continuously variable transmission.
Okay.
We went with that design choice. Last year had a similar layout, but it was with the flyway type CVT. And for this application, it's really hard to tune it. The weights don't go heavy enough, the springs don't go light enough. There's a lot of variations with track condition. By controlling the CVT electronically, we run into a similar theory as an IVT transmission, and we can control and monitor the speed of the engine and shift the CVT so it leaves the engine at peak power.
Because the whole goal is power to the ground, like power to the people, but in this case, power to the ground.
Correct.
So if it takes electronic controls, is there anybody around here who knows about electronic controls?
Dan or JT?
Dan.
All right.
I hear that your motto is I can. How do you spell I can?
IQAN.
And what is that?
What it is a controller that will take data from several sensors, and what the data is going to do is we are going to set a peak engine horsepower, or the peak engine speed to get maximum power out of it. Careful, that's expensive. And from this, we are going to use this to control the H-bridge that will control the actuator, which will send a signal to shift the actuator in or out, which will squeeze the primary, changing the ratio.
And so contrary to probably what most people think, this little tractor here does have a controller in the network.
It does. It does.
Sophisticated.
The joystick can interface with the MDL. So the only wires that you have to wire to the joystick are power, and you only need one wire harness out of the two. You just wire up power, and then from there the CAN wires, and then it all talks between the controller and the joystick.
So you programmed it using ICANN design software, ICANN by Parker?
Yes, by Parker.
I think Parker actually hires a lot of graduates from this program.
I think they do.
And I hear you're a pretty good ICANN debugger?
Yes, it's a learning process, and it's gotten better and better.
Okay, so it can take signals of lots of different types.
Yes.
And then power lots of different types to actually do intelligent control.
Yes.
So you're going to be able to use that skill until you retire.
Correct. Correct.
So JT, I hear ICANN can also not only control, but it could also collect data. Is that right?
True.
Are you the DAC guy?
That is my part of the senior design.
What's DAC?
Data acquisition system.
So how's that work?
So we're just gonna, for analysis purposes, we're gonna record as much data off of the tractor as possible. So we're gonna watch wheel speed, engine speed, ground speed. We'll measure things like intake and exhaust gas temperatures. Could give us an idea of engine performance. This year I've implemented a a very cheap microcontroller, which will log all of that data onto an SD card, and then it can be uploaded to a computer for analysis.
So this isn't just a tractor; it's like a completely instrumented tractor.
It's true.
What are you gonna do after you graduate?
I am going to grad school.
What are you gonna study?
I haven't decided yet. With Dr. Buckmaster, Autogenic Technologies.
More hardware, software,
Hardware, software interface, smarter tractors.
smarter tractors. Okay, was your job the operator station? Is that it?
Yeah.
So hop in, show me how are you going to drive this tractor?
So we have a steering column here. The TRW donated steering column for us, and basically this part is what TRW gave us, and we made this steering valve bracket to hold the steering valve here, and yeah, and this steering column can be adjustable, and so we give the operator comfortable driving from that steering column, and the power, and that part is the pump. So the power from the engine is going to the pump to driving this power steering to work.
So it is power steering just like any other power steering vehicle?
Yeah, we have a cylinder here at the front end. It's also from the bowhead, so it's shipping to us a package with that front end, and so the hoses will be connected between the pump and the steering valve, and to make it work. Yeah, and we have the paddle, brake paddle for each wheel.
Independent brakes, gotcha.
Yeah, so we can brake either paddle separately, and that paddle is a clutch paddle.
Okay.
So what else? And we have a swivel and slide stick bracket. So when the operator want to get onto the tractor, they can easily get onto it because it's give What's up?
So Jacob, it looks like a pretty skeleton of a tractor. Is weight an issue on this whole deal?
Yes, we are limited to 800 pounds. That's unballasted and without a driver.
Including the engine.
Including the engine, which is...
Engine, transmission, frame, tires.
Yes, that all has to be under 800 pounds.
800.000.
Yes, and the engine itself is 150 of that, so everything has to be as lightweight as possible.
Okay, so how do you, as an engineer, come up with a frame that's structurally sound but doesn't weigh too much?
We use a lot of like computer software, and what we can do is draw it up and using Pro Engineering 3D software. And
Is that a model of it over
yeah,
there?
there's
Let's take a
a
look. Let's
model
take a
of it
look.
over here. This is our model that we draw up in Pro E. It lets us show like how things are actually going to go together, makes a prototype before we actually build the real thing. It lets us know like where we're going to run into interferences, and helps us get an idea of what we're doing exactly.
That looks good. There's some fancy colors on this. Explain this whole graph.
That is FEA testing, stands for finite element analysis. What we can do is load in a part, like this is our front axle bracket that will connect the tires here to the frame itself. What we do is we can come through here and put forces that you would see under normal driving conditions, and then it can calculate like how much shear stress is going to be seen during the pull or during your driving conditions, and it'll let you know if the part is going to fail or if it's okay to actually build this and you can actually use it.
So I'm curious, Jacob Dinesh, this looks like fun, but having seen you in the building over and over and over, it also looks a little bit like work.
Oh yes.
Was it more work or more fun?
Right now more work. It'll be more fun when we're actually out playing on it, driving it around and winning the tractor pull.
I think it's pretty fun. Pretty stressful right now, but overall pretty fun. Looking back on it.
Okay. I'm also very curious. You're in ag and biological engineering, or agricultural engineering at Purdue University. Did you take any courses related to this topic, or you just come up with it on your own? A little bit of both.
A little bit of both. I was interested in it basically from the freshman on, but our machine machine design class that we take, and then I took a class with this guy on design of off-highway vehicles, and we learned a lot about peak power and power performance, and kind of helped spur the idea of how it would actually work.
My final parting question: with the design of all this, did we use any spreadsheets?
Yeah,
Awesome.
a lot.
Okay. So we're reporting from Purdue, Ag and Biological Engineering, having a little bit of fun, a little bit of stress, a little bit of work.